All right, calculus, here we are ready for your notes video for Monday, November 20th, 2023. Here are folks. We are brought to you by The Lore of Running. Yes, international bestseller. And our boy, Peter Attia, Outlive. That's what you guys want to do. All right, so put those on your Christmas list. All right, here we are, folks. Calculus notes for Monday, the 20th. We want to do this every now and then. We want to look at the SIU Calc 1 final exam. All right, this is from one of their past finals. Evaluate each limit. You guys will be taking, your fall final here for me very, very quickly, very soon. This will be a great question. So evaluate each limit. The limit as x goes to 0 of this right here. You might want to try this question first on your own. See if you can handle it. This would be a great question. Obviously, if it's on SIU's final, then the chance of it being on my final is very, very high. All right, we're going to multiply by the conjugate. Some of us are forgetting to keep the conjugate in the denominator, all right? So we know the constants cancel, we know this cancels, but we forget about the conjugate in the denominator. And this question itself might have been on a quiz recently. It's a great question. 1/8, all right? You are the second of 3 videos I'm going to make today, so pause this if you need to. Try this, pause it, do the question. Now, number two, I'm going to show you what would be good for me, but then also better for next year. Again, depending on if you're going to take Calc 1 again, look here. All right, so here's the question. The limit as x goes to infinity of this root over 3x. All right. So for me, you can say this is essentially the limit as x goes to infinity of, I almost made a boo-boo here, the root 81x to the second over 3x. These two are inconsequential, which is exactly the limit as x goes to infinity. The square root of 81, square root of x squared, 9x over 3x, which is 9 over 3, which is 3. Next year, though, here's a better way. Look, if you want, look at the numerator. Highest power is x. So I'm going to divide everything by x. But remember, if it's inside the root, then x is actually x squared. The square root of x squared is x. So I'm going to divide by x down here while in the root dividing by x squared. Because again, the square root of x squared is actually x. So I got to be consistent. Okay, I can't divide everything up here just by x because then I'm dividing by half a power less. So when I do that, when I divide everything essentially by a power of x here, up top I'm left with this. Now I can let x go to infinity because this is going to be 0 and this is going to be 0. 4 over infinity, 9 over infinity are both 0. So then I get the square root of 81 over 3, which is 9 over 3, 3. So know both, but again, next, if you're going to Calc 1 again at the on-campus university, know how to do it that way. Both from the final. Here are 2 more from the final, folks. Take a look at this. The limit as x goes to -2. And you guys are going to have your final exam review guide, I believe, Monday the 27th. Okay, if not, Tuesday the 28th. You guys are going to have it soon. So I'm going to factor 2 minus x plus 2. Okay, so we get in the habit, when we see this, we always think a lot of the times it's going to cancel, be a -1, but no, these just cancel. They just cancel. Not to be -1, they just cancel. And I get 4. I get 4. You will definitely, both on the fall final and your 3-day final in the spring, have a question like this. Find f prime of x using the limit definition of a derivative. Okay, so you can't simply say it's -4x plus 1. That's good that we know it's -4x plus 1, but we got to use the limit definition, which is f prime of x is the limit as h goes to 0 of f of x plus h minus f of x over h. This is f of x plus h minus, make sure this is all in parentheses, f of x. All right, so I'm doing the algebra. Again, pause this right now if you just need to do it. I want to make sure that we can do that. Our algebra is getting better. All right, I'm not canceling anything. Like I'm not canceling these out yet until bam, this step right here. I'm going to make this kind of quick so that, we can use the rest of the time to work on a lot of our homework. Obviously, homework sets 1 is due Tuesday, but Homework set 2, a ton of it can be done, as we now have essentially fully talked about, and we will hear a little bit more, the quotient and the product rule. All right, we got those trig derivatives down. Divide everything by h. Now let h be 0, negative 4x plus 1. So please use time wisely. Find the derivative of the functions. You do not need to simplify. All right, so yeah, this is an example. I told you this the other day. So they give you this type of question, and the other derivatives they had on there won't be a challenge for us soon. They just require the chain rule. We need to talk about the chain rule either Tuesday. We might start talking about it on Tuesday, or when we come back from Thanksgiving. Low d high minus high d low all over the square of what's below. Low d high minus high d low all over the square of what's below. That would probably be good. I mean, they said you don't need to simplify, so they're not asking you to FOIL this or distribute this. That would probably be good for them. All right. We're getting a lot of this already, acing it. Find the equation of the tangent line to y is x cosine x plus sine x at x equals pi. So that's the x value. Again, the y value is going to be here. Plug pi in for x. Pi cosine pi plus sine pi. A lot of pi. Pi's right here. So x is negative 1 and y is 0. So your y value is going to be a negative pi. So to find the slope of the tangent line, we need to find the general derivative. So product rule, derivative of the first times the second, plus the first times derivative of the second, plus, what's the derivative of sine x? We did something like this the other day. Derivative of sine x is simply cosine x. All right, so there's my general derivative. Now to find the slope of the line anywhere, I plug pi in for x. And there you go, I'm going to get negative 2. Y minus the y value is equal to slope times x minus the x value. All right, now this is from the book. This is from the book. All right, so differentiates. So, yeah, I would, if this was on a homework or something, maybe in a quiz, I'd probably have you do the math. Okay, so low d high minus high d low all over square of what's below. There it is. Low derivative of the top minus the top derivative of the bottom all over square of what's below. We don't need to FOIL that or distribute that. That's a 3 by 3. That'd be 9. So try my best here. There you go. There you go. Draw the arrows. There you go. Boom, boom. I'm feeling pretty good about that. That is first, outer, inner, last. And I'm subtracting all of it. So you can fit all that in there. Many little boo-boo with the exponents and the coefficient. But I'm feeling pretty good that this simplifies right here. So that's y prime. Y prime. Feeling pretty good about that. And yeah, it's a lot of algebra. All right, but especially on a homework set, we can handle it. Maybe it'd be a little bit milder on your quiz. We can do that one. All right. Again, pause this, get this down if need be. F of x. So you do not need to use the product rule. You could do derivative first times second plus first times derivative second. A lot of 1/2s, a lot of roots in there. Instead, if I just first, outer, inner, last, guys, these are conjugates. Okay, these are conjugates. It's simply going to be x squared minus x. So the derivative is 2x minus 1. If you can simplify something first and then just use the basic power rule, that's what you want to do. Easy peasy. All right, and here's another example of just that. Yes, if I gave you something like that, f of x is blank. Just FOIL it. Okay, just FOIL it. You're dealing with negative exponents, but you can handle that. First, outer, inner last. And then we, let's see, simplifying here. So x minus x to the negative first, minus 2x to the negative third. And then bring down the power 1 power less, bring down the power 1 power less. Derivative of x is 1. Awesome. Lastly, before a little surprise for those of us that are watching it at the appropriate time, which is in class, is the following. We're going to do this, and then a quick little surprise that stats sometimes has. Derivative of the first. So I would do the product rule here, because if you distribute, you're then going to have to do the product rule here. You're not getting out of the product rule. So I would call this the first, that's the second. Derivative of the first would be 2x plus e to the x times the second plus the first function times the derivative of the second. So, this is x to the 1/2. I would rewrite that. Bring down the power 1 power less. Okay. Can't really rewrite that except for putting the root x out front plus, all right, so it's going to be this in the numerator and 2 in the denominator, and x to the negative 1/2 is root x. Okay, folks. Okay. I just want to make sure because, unfortunately, sometimes you need to do this, and this will reward people who are watching videos in class like they are supposed to, because you're in calculus class. And even though I'm not here, guys, you could have grades. So this is actually worth some points. And I've done this now twice in stats, and we need, I think, a few more points. There's the sirens here in town, my town. Anyway, this is for 5 points, okay? So we're going to do this example. So on a separate sheet of paper, right now on a separate sheet of paper, write your name, okay? Write the date, 11/20/23, questions from notes video. And if you didn't watch this class and you see it later, or you were gone, you're going to have to email me, and you're going to have to let me know. Because this can happen, and this is fair. All right, so example 1. And I want to see who is actually doing what they're supposed to do when I am gone. Folks, in fact, we just need to know how to do this too. So you're going to turn this in, but you also might want to write this down on a separate sheet of paper as well. So, yeah, what is, I almost spelled it wrong. We might just do 2 of these here. What's the derivative of cosecant? So if I ask you that, so you can, look that up. You can actually look that up, and that does not look good. You could look that up, and it's going to have a derivative. Or, if you can't memorize that, remember it's 1 over sine. All right, so low d high minus high d low all over the square of what's below. So it is negative cosine over sine squared x, which, as you'll see, will be written like this. It is negative cotangent cosecant, or negative cosecant cotangent. It might be like that because you're beginning with cosecant. All right, so there you go. But you can do the quotient rule instead of trying to remember that. So that was good. And then, so we're going to have this down because you're going to turn this into me here in a few minutes. Example 2. Cotangent. And again, this is just an intangible, who's doing what they're supposed to do at the appropriate time. Okay, this is no gotcha. And if it is a gotcha, then hopefully you learn a lesson. Okay, so what's the derivative of cotangent? Well, cotangent is cosine over sine. So low d high minus high d low all over the square of what's below. So look what's going up top. this is the opposite of sine squared. I can factor out a negative. This is the opposite of sine squared plus cosine squared over sine squared. Sine squared plus cosine squared, this is 1. So this is the opposite of sine squared theta, which is the opposite of cosecant squared theta. So remember how the derivative of tangent was secant squared? And the derivative of cotangent is the opposite of cosecant squared. Interesting. So the derivative of, what was it, secant was secant tan, and the derivative of cosecant is negative cosecant cotangent. So, you know, you can see some similarities there, but I think quotient rule on those, you don't necessarily have to have those memorized. All right, great. So when you're done with that, which is, you know, if the directions have been clear, all right, at the end of the hour, turn this in. So make sure you leave class by, make sure in the top tray you've turned this in. All right, with your name on it. Okay, and if you weren't here, you should be emailing me. You got 24 hours to email me. Let me know. I'll check that with the attendance. All right, but that's 5 points there. All right, that is Yak Math Videos signing out. I will see you on Tuesday.